Hello and welcome to MBKM Models. Today we're going to talk about the Gerald R. Ford-class aircraft carrier. The Gerald R. Ford class is a class of nuclear-powered aircraft carriers currently being constructed for the United States Navy. The class, with a planned total of 10 ships, will replace the Navy's current carriers on a one-for-one basis, starting with the lead ship, Gerald R. Ford, replacing Enterprise, and then eventually taking the place of existing Nimitz-class carriers. The new vessels have a hull similar to the Nimitz-class, but introduce technologies since developed with the 21 program, such as Electromagnetic Aircraft Launch System, as well as other design features intended to improve efficiency and reduce operating costs, including sailing with smaller crews. This class of aircraft carriers is named after former US President Gerald R. Ford. The first ship of the class, CVN-78, was procured in 2008 and commissioned into service on the 22nd of July 2017. The second ship of the class, John F. Kennedy, CVN-79, is expected to be commissioned into service in 2024. The biggest visible difference from earlier supercarriers is the more aft location of the island. The Gerald R. Ford class carriers will have a reduced whole life cost, due in part to reduced crew size. These ships are intended to sustain 160 sorties per day for 30 plus days, with a surge capability of 200 sorties per day. Director of Operational Testing Michael Gilmore has criticised the assumptions used in these forecasts as unrealistic and has indicated sortie rates similar to the 120 to 240 per day of the Nimitz-class would be acceptable. Development. The current Nimitz-class aircraft carriers in the US Naval Service have been part of the United States power projection strategy since Nimitz was commissioned in 1975. Displacing about 100,000 tons when fully loaded, a Nimitz-class carrier can steam in excess of 30 knots, 56 mile an hour or 35 mile an hour, cruise without resupply for 90 days, and launch aircraft to strike targets hundreds of miles away. The endurance of the Nimitz-class is exemplified by USS Theodore Roosevelt, which spent 159 days underway during Operation Enduring Freedom without visiting a port or being refueled. The Nimitz design has accommodated many new technologies over the decades, but it has limited ability to support the most recent technical advances. As a 205 RAND report said, the biggest problems facing Nimitz-class are the limited electrical power generation capability and the upgrade-driven increase in ship weight and erosion of the center of gravity margin needed to maintain ship stability. With these constraints in mind, the US Navy developed what was initially known as the CVN-21 program, which evolved into the CVN-78 Gerald R. Ford. Improvements were made throughout developing technologies and more efficient design. Major design changes included a larger flight deck, improvements in weapons and material handling, a new propulsion plant design that requires fewer people to operate and maintain, and a new smaller island that has been pushed aft. Technological advances in electromagnetics have led to the development of an Electromagnetic Aircraft Launch System, EMALS, and an Air Advanced Arresting Gear, AAG. An integrated warfare system, the Ship Self-Defense System, SSDS, has been developed to allow the ship to more easily take on new missions. The new dual-band radar, DBR, combines S-band and X-band radar. These advances will allow the new Gerald R. Ford class carriers to launch 25% more sorties, generate triple the electrical power with improved efficiency, and offer crew quality of life life improvement. Flight deck. Catapult number 4 on the Nimitz-class cannot launch fully loaded aircraft because of low wing clearance along the edge of the flight deck. Movement of weapons from storage and assembly to the aircraft on the flight deck has also been streamlined and accelerated. Ordnance will be lifted to the centralized rearming location via higher capacity weapons elevators that use linear motors. These elevators are located so that ordnance need not cross any areas of aircraft movement, thereby reducing traffic problems in the hangars and on the flight deck. In 2008, Rear Admiral Dennis M. Dwyer said these changes will make it hypothetically possible to rearm the planes in minutes instead of hours. Power generation. The new Bechtel A1B reactor for the Gerald R. 4 class is smaller and simpler, requires fewer crew, and yet is far more powerful than the Nimitz-class A4W reactor. 2 reactors will be installed on each Gerald 4 class carrier, providing a power generation capacity of at least 25% greater than the 550 MW thermal of the 2 A4 reactors in a Nimitz-class carrier. The portion of the thermal power allotted to the electrical generation will be tripled. The propulsion and power plant of the Nimitz-class carriers were designed in the 1960s when onboard technologies required less electrical power. The new technologies added to the Nimitz-class ships have generated increased demands for electricity. The current base load leaves little margin to meet expanding demands for power. The Gerald R. 4 class ships convert steam into power by piping it to 4 main generators, MTG, to generate electricity for major ship systems, and the new electromagnetic catapult. The Gerald R. 4 class ships use steam turbines for propulsion. A larger power output is a major component to the integrated warfare system. Engineers took extra steps to ensure that integrating unforeseen technological advances onto a Gerald R. 4 class aircraft carrier would be possible. The Navy expects the Gerald R. 4 class will be part of the fleet for 90 years until the year 2105, which means that the class must be successfully accept new technology over the decade. Only half of the electrical power generation capacity is used by currently planned systems, with half remaining available for future technologies. Electromagnetic Aircraft Launch System. The Electromagnetic Aircraft Launch System, EMALS, launches aircraft by means of a catapult employing a linear induction motor rather than the steam piston used on the Nimitz-class. The EMALS accelerates aircraft more smoothly, putting less stress on their airframes. The EMALS also weighs less, is expected to cost less and require less maintenance, and can launch both heavier and lighter aircraft than a steam piston driven system. It also reduces the carrier's requirement of fresh water, thus reducing the demand for energy intensive desalination. Arresting gear landing system. Electromagnets are also being used in the new Advanced Air Resting Gear System, AAG. The current system relies on hydraulics to slow and stop a landing aircraft, while the hydraulic system is effective, as demonstrated by more than 50 years of implementation. The AAG system offers a number of improvements. The current system is unable to capture unmanned aerial vehicles, UAVs, without damaging them due to extreme stress on the airframe. UAVs do not have the necessary mass to drive the large hydraulic piston used to trap heavier manned airplanes. By using electromagnetics, the energy absorption is controlled by a turbo-electric engine. This makes the trap smoother and reduces shock on airframes. Even though the system will look the same from the flight deck as its predecessor, it will be more flexible, safe and reliable, and will require less maintenance and manning. Sensors and self-defense systems. Another addition to the Gerald R. 4 class is an integrated active electronically scanned array search and tracking radar system. The dual band radar, the DBR, was being developed for both Zumwalt class guided missiles destroyer and the Gerald R. 4 class aircraft carriers by Raytheon. The island can be smaller by replacing 6 to 10 radar antennas with a single 6-face radar. The DBA works by combining the X-band AN-SPY3 multifunction radar with the S-band volume search radar, the VCR. Emitters distributed into 3-phased arrays. The S-band radar was later deleted from the Zumwalt destroyers to save money. The 3 faces dedicated to the X-band radar handle low altitude tracking and radar illumination, while the 3 S-band faces handle target search and tracking regardless of weather, operating simultaneously over 2 electromagnetic frequency ranges. The DBR marks the first time this functionality has been achieved using 2 frequencies coordinated by a single resource manager. This new system has no moving parts, therefore minimizing maintenance and manning requirements for operation. The ANSPY3 consists of 3 active rays of the receiver exciter REX, cabinets above decks, and the signal and data processor SDP subsystem below decks. The VSR has a similar architecture with the beamforming and narrowband down conversion functionality occurring in 2 additional cabinets per array. A central controller, the resource manager, resides in the data processor, the DP. The DBR is the first radar system that uses a central controller and 2 active array radars operating at different frequencies. The DBR gets its power from the Common Array Power System, CAPS, which compromises power conversion units, PCUs, and power distribution units, PDUs. The DBR is cooled by way of a closed-loop cooling system called the Common Array Cooling System, the CACS. The Enterprise Air Surveillance Radar, EASR, is a new design surveillance radar that is to be installed in the second Gerald R. 4 class aircraft carrier, John F. Kennedy, CVN-79, in lieu of the dual-band radar. The Nimitz-class amphibious assault ship, starting with LHA-8 and the planned LXR, will also have this radar. The EASR suite's initial per unit cost will be about $180 million, less than the DBR, for which the estimate is about $500 million. Possible upgrades for future defense systems such as free electron laser directed energy weapons, electric armor, and tracking systems will require more power. Only half of the electrical power generation capability on CVN-78 is needed to run currently planned systems, including EMALS. CVN-78 will thus have the power reserves that the Nimitz-class lacks to run lasers and electric armor. The addition of the new technologies, power systems, design layout, and better control systems results in an increased sortie rate of 25% over the Nimitz-class and a 25% reduction in manpower required to operate. Waste management technology will be deployed on Gerald R4, co-developed with the Cadarot Division of the Naval Surface Warfare Center. Pyrogenesis Canada Incorporated was in 2008 awarded the contract to outfit the ship with a plasma arc waste destruction system. This compact system will treat all combustible solid waste generated on board the ship. After having completed factory acceptance testing in Montreal, the system was scheduled to be shipped to the Huntington Ingalls shipyard in late 2011 for installation on the carrier. The Navy is developing a free electron razor, FEL, to defend against cruise missiles and small boat swarms. 3D computer-aided design. Newport News Shipbuilding used a full-scale 3-dimensional product model developed in Dassault Systems CATIA V5 to design and plan the construction of the Gerald R. 4 class of aircraft carriers. The CVN-78 class was designed to have better weapons movement paths, largely eliminating horizontal movements within the ships. Current plans call for advanced weapons elevators to move from storage areas to dedicated weapons handling areas. Sailors would use motorized carts to move the weapons from storage to the elevators at different levels of the weapons magazines. Linear motors are being considered for the advanced weapons elevators. The elevators will also be relocated such that they will not impede aircraft operations on the flight deck. The redesign of the weapons movement paths and the location of the weapons elevators on the flight deck will reduce manpower and contribute to a much higher sortie generation rate. Planned aircraft complement. The Gerald R. class is designed to accommodate the new Joint Strike Fighter carrier variant aircraft, the F-35C. But aircraft development and testing delays have affected the integration activities on CVN-78. These integration activities include testing the F-35C with CVN-78's EMALS and advanced arresting gear system, and testing the ship's storage capabilities for F-35C's lithium-ion batteries, tires and wheels. As a result of F-35C developmental delays, the US Navy will not field the aircraft until at least 2018, 1 year after CVN-78 delivery. As a result, the Navy has deferred critical F-35C integration activities, which introduces risk of system incompatibilities and costly retrofits to the ship after its delivery to the Navy. Crew accommodations. Systems that reduce crew workload have allowed the ship's company on Gerald R. Ford class carriers to totally only 2,600 sailors, about 700 fewer than a Nimitz-class carrier. The massive 180-man berthing areas on the Nimitz-class are replaced by 40 rack berthing areas on Gerald R. Ford class carriers. The smaller berthings are quieter and the layout requires less foot traffic through other spaces. Typically, the racks are stacked 3 high with locker space per person. The berthings do not feature modern sit-up racks with more headroom. Bottom and middle racks only accommodate a sailor lying down. Each berthing has an associated head, including showers, vacuum-powered septic system toilets, no urinals since the berthings are built gender neutral, and sinks to reduce travel and traffic to access facilities. Wi-Fi enabled lounges are located across the passageway in separate spaces from the berthing's racks. Since development, the two carriers of the class have run into problems with the plumbing of the waste system. The pipes were too narrow to handle the load of users, resulting in the vacuum failing and repeatedly clogged toilets. To alleviate the problem, specialized acidic cleaning solutions have been used to flush out the sewage system. These cleaning treatments cost about $400,000 each time, resulting in a substantial unplanned increase in the lifetime expense of operating these ships, according to the GAO. These cleanings will have to be performed for the lifetime of the ship. Medical facilities. Gerald R. Ford, first in the class, has an onboard hospital that includes a full laboratory, pharmacy, operating room, 3-bed intensive care unit, 2-bed emergency room, and 41-bed hospital ward, staffed by 11 medical officers and 30 hospital corpsmen. Construction of the first vessel in the CVN-78 Gerald R. Ford officially began on the 11th of August 2005 when Northrop Grumman held a ceremonial steel cut for a 15-ton plate that would form part of a side shell unit of the carrier, but construction began in earnest in early 2007. The carrier was assembled at Newport News Shipbuilding, a division of Huntington Ingalls Industry, formerly Northrop Grumman Shipbuilding, in Newport News, Virginia. This is the only shipyard in the United States that can build nuclear-powered aircraft carriers. In 2005, Gerald R. Ford Ford was estimated to cost at least $13 billion, $5 billion for research and development, plus $8 billion to build. In 2009, report raised the estimate to be $14 billion, including $9 billion for construction. In 2013, the life cycle cost per operating day of a carrier strike group, including aircraft, was estimated at $6.5 million by the Center for New American Security. Originally, a total of 3 carriers were authorized for construction, but if the Nimitz-class carriers and Enterprise were to be replaced 1 for 1, 11 carriers would be required over the life of the program. The last Nimitz aircraft carrier is to be decommissioned in 2058. In a speech on the 6th of April 2009, Secretary of Defense Robert Gates announced that each Gerald Ford class carrier would be built over 5 years, yielding a more fiscally sustainable path, and a 10 carrier fleet after 2040. That changed in December 2016 when Navy Secretary Ray Mabus signed a force structure assessment calling for a 355 ship fleet with 12 aircraft carriers. If enacted, this policy would require each Gerald Ford class carrier to be built in 3 to 4 years. First of class type design changes. As construction of CVN-78 progressed, the shipbuilder discovered first of class type design changes, which it will use to update the model before construction of remaining vessels of its class. Several of these design changes were related to EMALS configuration changes, which required electrical wiring and other changes within the ship. The Navy anticipates the additional design changes stemming from remaining advanced arresting gear development and testing. According to the Navy, many of these 19,000 changes were programmed into the construction schedule early on, a result of the government's decision at contract award to introduce improvements onto the ship's warfare systems during constructions, which are heavily dependent on evolving commercial technologies. Naming. There was a movement by the USS America Carrier Veterans Association to have the CVN-78 named after America rather than after President Ford. Eventually, the amphibious assault ship LHA-6 was named America. On the 27th of May 2011, the US Department of Defense announced the name of CVN-79 would be USS John F. Kennedy. On the 1st of December 2012, Secretary of the Navy Ray Mabus announced that CVN-80 would be renamed USS Enterprise. The information was delivered during a pre-recorded speech as part of the deactivation ceremony for the previous Enterprise. CVN-65, the future Enterprise CVN-80, will be the 9th US Navy ship to bear this name. On the 20th of January 2020, during a ceremony in Pearl Harbor, Hawaii, on Martin Luther King Jr. Day, Acting Secretary of the Navy Thomas B. Modley named a future Gerald R. Ford class aircraft carrier in honor of World War II hero Doris Miller. This will be the first aircraft carrier named for an African American and the first aircraft carrier to be named for a sailor in the enlisted ranks. It is the second ship named in honor of Miller, who was the first African American to be awarded the Navy Cross. Thanks for watching, thanks for listening, and until next time, I hope you've enjoyed it. Please don't forget to like and subscribe, and I will see you all in the next video.